Very good morning to one and all. Today we are going to see about a small problem in the Thevenin's theorem. As we have seen the Thevenin's theorem before, any linear bilateral DC network can be complex DC network can be converted into simple network by with the equivalent Thevenin resistance, that is VTH, and equivalent resistance RTH, that is connected in the parallel with the load resistance. Say for example, this the problem is given. So here the voltage source is 5 volts and R1 is 2 ohms, and here this R2 is 6 ohms and R3 is 4 ohms, and load resistance is 5 ohms. So first, if you the problem is given, you just mark this load resistance point here as A and B, just for our reference. Okay, E and B are X and Y. So whatever the thing you want, you just mark here as E and B. So for simplification, we are marking these 2 points as E and B. So now, what is the first step? We need to open the load resistance. So first we are opening our load resistance. That is 5 ohms. We are opening the load resistance to find out the VTH. So open circuit the load resistance. That is this thing. So if you open this, the current will not flow to this particular path. Okay, the current will not flow to this particular path. So here again we are neglecting here. So for finding out the VTH, again we are neglecting this 4 ohms. Even though if the current flows here, there will be no change. So we are neglecting this thing. Now we are finding out the VTH by opening the load resistance. So again we are neglecting this particular this R3, because here even though current flows, there will be no change, because here it is open circuit. So we are neglecting here. So now the circuit becomes, here it is 5 ohms, here it is 2 ohms, here it is 6 ohms. Now we are finding out the current I in this particular path. Okay, so I is nothing but by Ohm's law, I is equal to V by R. So V is equal to I is equal to V by R. So V, that is 5 ohms divided by this 2 ohms and 6 ohms are connected in series. So we are adding the total resistance. So 5 divided by 2 plus 6, that is I is equal to 0.62 amperes. So this to find out the current. Now we need to find out the VTH. So VTH is nothing but I into R2. Okay. So here, so I into this R2. So here we are finding out the voltage across this particular point. So I into R2 is nothing but 0.62, that whatever calculated amps, into this R2 is 6 ohms. So that is nothing but VTH. That is 3.72 voltage. That is the VTH. Now VTH is fine. So for to finding out the RTH, what we need to do is we need to short this voltage source. So this is the circuit already there. Now we need to short this voltage source. So if you short this voltage source, there are 3 resistance are there. That is R1, R2, and R1, R2, and R3. So now this 4 and 6. So you need to come from this right hand side. Okay, always you need to solve the sources from the right hand side. So if you facing the circuit, it is from your right hand side. If it is for the in the circuit point of view, it is the left hand side. Okay, so either way you take, but anyhow we are facing the circuit, no, so it is you need to solve from this side, so right hand side. So this 4 ohms and 6 ohms are in parallel. So 4 and 6 ohms are in parallel means so it is nothing but this 4 into 6, sorry. Yeah. So here in either way you can solve. Okay. So 4 ohm and 6 ohm. So here it is solved like 2 ohm and 6 ohm are in parallel, and this particular this two in series, like that. So like that also you can solve. So say for example, if you solve like 4 ohm and 6 ohm and series plus this 2 ohms, that also either way it will give the same answer. Okay. Say for example, if I'm doing 2 ohm and 6 ohm are in parallel, and again with that resistance, again this two are in series, that also same. So if you find it will the Thevenin's that is equivalent resistance will come like 5.5 ohms. In either way, say if you take 4 ohms parallel with 6 ohms, and again that answer with the whatever the answer, that equivalent resistance, and again 2 ohms in series, that also will give you the same answer. So now we found out the R Thevenin, that is 5.5 ohms. Here, R Thevenin we found out. Now, B Thevenin already we found out as 3.7. So this is the Thevenin's diagram. Now we are adding the load resistance, load resistance RL, that is 5 ohms, to this Thevenin, that is V Thevenin, R Thevenin, and this load resistance. All should be in the series. That is the theorems, steps, okay, rules. So now we are introducing, now we need to find out the load current, IL. IL, how to find out the IL? So IL is equal to VTH, that is by ohm logging. So VTH divided by these two resistance are in series. So we need to add the RTH plus R. So VTH is 3.72 divided by RTH is 5.5 plus RL is 5. So if you simplify this, we are getting the load current as 0.354 amperes. So this is the load current for this particular circuits, for this particular circuit, while solving by using the Thevenin's theorem.